So all of you open that HR analytics sheet. The HR analytics things where we have done hypothesis test and all. Cell, run all cells. Okay, HR analytics. Hey, you got the file? You send in the file and you meanwhile you download from analytics with that. You have the data sets. You simply give the folder path and that file names will automatically read and you can run it. You also got it? You don't have. Send to her also, no? Meanwhile, you download that analytics with the HR analytics data sets, train test, and save them into a folder called HR analytics. So that you can give the path and then you can import the files. Got it, all of you? We logistic regression, right? Earlier we worked on logistic regression. Wherein we got an accuracy of 91.72, right? From sklearn dot tree import decision tree classifier. Because this is classification data, we are using decision tree classifier. Tree is equal to decision tree classifier. Tree model is equal to tree dot fit x comma y. Tree model tree dot fit x comma y. Tree model dot score x comma y. See 99.74. You got 99.74, almost closer to 1. Almost closer to 1. Right? 99.97. If you round it off, it will be 1 only. Now, what is this overfitting problem? See, we are seeing this overfitting problem. Overfitting problem is two things. Accuracy close to 1 or R square close to 1, right? Another thing is on cross validation, accuracy drastically falls to lower levels. The other problem with overfitting problem is on train data you got 99.74, right? On train data you got 99.97 or 99.97. But if you repeatedly test it, there will be drastic change in accuracy. That is also called as overfitting problem. Two things in overfitting problem: accuracy close to 1 or R square close to 1 if it is a regression problem. On cross validation means repeated testing. On cross validation, the accuracy levels will drastically fall. Now, from sklearn dot model selection import cross underscore val underscore score. Cross underscore val underscore score, the model name is tree, comma x, comma y, comma CV is equal to 5. So what cross validation will do is, it will subset the data into 5 samples of data and run the same model with that 5 samples of data. And each time it will calculate the accuracy. See here, 90, 89, 89, 90. Okay, this is not the bad score. This is a good score for this data set. But on some situations, what happens is you will get 99.9 on train data. On repeated testings, these scores will be 60, 0.60, 0.70, like that. We will see. Here it is okay. Cross validation is bringing close to 90%. But in some other data sets, you will see this cross validation will generate scores like 0.53, 0.60, 0.70, like that. There's a huge difference. That we call it as overfitting problem. That we will call it as overfitting problem. And this overfitting problem, we cover it up with using max depth. Max depth can be used to cover up this overfitting problem. సార్ అది ట్రాన్స్పోర్టేషన్ ఛార్జెస్ ఎంత చెప్తే అది కూడా యాడ్ చేసి పంపించేద్దామని. అదే అతనికి ఇవ్వచ్చా? ఓకే, అదేదో అమౌంట్ మీరు చెప్తే అతను చెప్తాడా లేకపోతే అతను చెప్తాడా? ఓకే ఓకే సార్. ఓకే ఓకే ఓకే. హలో, అదే రైట్ అండి, నేను అతనే ఇవ్వమని చెప్తాను. ఓకే, నేనైతే ఇప్పుడు అమౌంట్ ట్రాన్స్ఫర్ చేస్తున్నాను మీకు ఇమీడియట్గా. ఓకే రైట్. Got it? All of you got it or still errors? What is the combined DF dot shape? 61. Seven, eight, two, nine, eight, right? HR perspective, HR this is important challenge. That is actually interest change. Trained by the money is it problem. Same, you have to start from all of this at the beginning. Anybody has 54,000. So I think the wrong side got up. అప్పుడు ఏదో మంచి రావాలి 50,000 54, right? Yeah. Then you can run all the cells. Okay. So decision tree classifier, right? All of you got this? Then after this DT classifier, from sklearn dot tree, sorry, dot tree import plot underscore tree. ELT dot figure text size is equal to 30, 30 plot underscore tree model max underscore depth is equal to 4. To see this tree, because what happens is it will print a very large tree. So this is the decision tree it has printed. 4-level tree. It's running. Plot underscore tree. sklearn plot underscore tree, you can see the decision tree. Feature names is equal to x dot columns. Now, if you can see the tree here, you will see the model of the tree. It's not fully shown, but you can see here. Root node is average training score less than equal to 98.5. Okay, you can see the average training score. Open image in new tab. So you can see here open image in new tab. Average training score less than equal to 90.5, I think, or 96.5 something. Gini is 0.356. You can see here, right? You can play with the font size also. 1 second. Class names label all filled is equal to true. Font size is equal to So you can see the tree structure. I think you can see here. You can open it in a new window and you can see it. So you can see the tree model. You can also get the tree survey, tree model, complete tree model. Okay. So we got the decision tree model. We also got the tree, right? Hmm. Yeah. You can plot the tree. Four level tree. I told you now we can control the depth of the tree. How many layers you want in the tree? So we are seeing only the four layers in the plot. Actually, in the back end, it will build a very large tree. 30 layers, 20 layers tree will be there. But we can't see that all, right? Ah. Done. So we have built the decision tree model here. Decision tree classifier. We have given a short name as tree. Then tree model is equal to tree dot fit x comma y. Score is, what is the score here? Accuracy. Accuracy from confusion matrix. For all classification problems, you will get accuracy. So in the back end, as part of the model process, it will calculate the confusion matrix and it will also calculate the accuracy. So this model has 99.97 accuracy, almost 1. Now, generally, the biggest disadvantage decision tree has is overfitting problem. Too good to be 2 or closer to 1. Now, how do we check overfitting? Using cross-validation. We can check overfitting using cross-validation. Cross-validation means repeatedly testing the same model with same data. What happened? So with same data, you are repeatedly testing the model. Same model will be tested with the same data again and again, right? So we are testing it 5 times and we are getting the score of each iteration. The score of each iteration is, we got the cross validation score of 89 or something like that, we got it, right? So we got the iteration scores. Here it is better, but in some cases you will see the scores are very worst. During some situations, the score will be very, very bad. So, whenever we have this overfitting problem, you have to do max depth adjustment of the decision tree using max. Keep it open. Keep it open. Okay, leave it. Leave it. Max depth we have to control. Right. So once you control using the max depth, you will get the cross-validated scores, and then you check the cross-validation. And then we plotted the tree here. If you want, you can. If you want to see the complete tree, we can export it into a Word document, and then we can see the complete tree also. Okay. Now, we can also see the text version of the tree. Generally, earlier we used to see the text version from sklearn.tree import export underscore text. Export underscore text tree model, comma, feature names is equal to x dot columns. Oh, okay, 1 second. Text. Max depth is equal to See here. Export text, you can see here. Feature 3 less than equal to feature names explode columns is not working. Okay. All right. We will go with feature names is equal to remodel dot feature names in. Okay. Remodel dot uh, without feature importances, we are getting it. With feature importances, we are not getting. So feature 3, 90.50. You can see the text output of the tree. Each and every node is plotted here. But export as variable names, precision tree, there is square bracket single quote features. R is equal to we're not getting the feature names. Okay. Print R. So you can see here the tree structure. You can see the tree structure. The same tree, what we have seen earlier in the graph form, this is the text version. So feature 3 is nothing but your what you call average training score. Average training score is the feature 3. That is a numerical variable, na? It has to be converted into binary. So less than equal to greater than. It randomly picked 90.50, less than equal to greater than. Is underscore promoted, yes or no. The table will be is underscore promoted, yes or no. And then greater than equal to 90.50, less than equal to less than 90.50, or greater than 90.50, less than equal to 90.50. Okay. So we got the tree version. Now, why we are not getting the feature names? That is what I have to check. Export tree. Feature names. You can also export it into text file. I will square bracket single quote feature names. I don't know why we are not getting feature names. Get underscore feature names is there. Remodel dot feature names. Okay. These things change constantly and they create problem. Feature names, it's not taking. But anyway, okay. We got the text version of the model, right? The next thing which is important is variable importance. Variable importance is another thing which you get in decision tree. PD dot data frame. PD dot data frame x dot columns, comma, tree model dot feature importances. Now you can see here which are the important features. Dot sort underscore index ascending is equal to false. Okay, so you can see the most important variable is average training score, followed by department, followed by age, region, length of service, and then previous year rating, and all of them are there. In this case, all of them are important. Hello? Hello? हाँ बोलो. हाँ हाँ वही. हाँ आप ना वो विद्यानगर पता है आपको, अडिकमेट फ्लाईओवर उतरने के बाद सीधा जाएंगे तो रिलायंस फ्रेश आएगा. हाँ नहीं नहीं आप सीधा तारनाके से आ रहे हो ना, आप सैनिकपुरी से आ रहे हो ना. सैनिकपुरी से आप वो सफीलगुड़ा रोड है ना, वो कोका कोला कंपनी रोड, वो सीधा आके हाँ हाँ वही तारनाका से यू टर्न लेके तारनाका से यूनिट वही रोड के बगल में वाई जंक्शन से वो अडिकमेट जाता है ना फ्लाईओवर, वो अडिकमेट फ्लाईओवर उतर के सीधा आ जाओ. सीधा आने के बाद राइट साइड में रिलायंस फ्रेश दिखेगा. रिलायंस फ्रेश बगल में एक मस्जिद है, मस्जिद गली में लेफ्ट साइड 5वां अपार्टमेंट साई मोहन एनक्लेव. आप कॉल करो. हाँ भाई वही कितना अमाउंट है. हाँ तो वही आप बोलो, आप दे देंगे. मैं नहीं हूँ, मेरे पेरेंट्स रहेंगे, वो लोग दे देंगे. मैं मेरे फोन कर दूंगा, उनको दे देंगे. ठीक. See, these are the variable importance which you need to find out. Typically, here we don't see, these are small variables, so we don't see any change. But when you have large variables, some of the variables will be zero. Some of the variables will be zero. That means they will be of no use, and you can delete them from your data. Okay. So this is another thing you need to understand when you are dealing with decision tree. Now, one more thing is decision tree is a rule-based prediction system, right? Like I told you, decision tree is rule-based prediction system. If see, it will create rules like this. If then if, right? If A is greater than 0.4, then if grade B is greater than less than 0.2, then if C is greater than, then it is class X. So it will create rules like this, right? So to see the rules, actually I'll send you the code. That is based on the Gini. Yeah. See, this is Gini. By default, it will take Gini. Feature importances are again calculated once the tree is completely built. Average training score is appearing more frequently. Average training score is appearing more frequently than any other variables. Then next less frequent variable you can see there. So that is how it will do. So initially it will take Gini. After building of the tree, which variable comes more number of times, that will be averaged out, and then it will give you the final feature importances. Less, na, we what we call less, Gini will always be less than 0.50. In this case, feature importance, the higher the value, the more it is important. In case of feature importances, it will be not Gini, it is something different calculated from the Gini only. But the higher the importance, the more the feature is important. We got the code, get rules. I'll email you this complex code, which is created to get the rules of the decision tree. Going to all. Yes, coming, but there is. Yeah, I've sent you the code. And I'm also pasting the code. I have to copy the code again. Control C, HR analytics. So this code will create a function called get rules. This we will create a function called get rules. Yeah. At least we printed the rules properly. Why it is not printing the rules?